So far this year, when we've been graphing things, everything has been more or less linear. It's made a straight line, and it's been fairly quick to graph. You just get a couple points and you're good to go. As you can probably imagine, though, not everything in life is going to make a nice, straight, neat line. There are all sorts of graphs out there that aren't just something you can draw with a quick ruler. The first main type we're going to talk about in this chapter, our focus is going to be on quadratic graphs. So graphs with x squareds tend to look like these shapes you see right here. They're curved, notice, and they almost look like a U. The official math name for that is called a parabola. So a parabola is this U shape that you're seeing on my graphs below. So that's definitely a word to be familiar with here, and we have just a little list of vocab words that we're going to talk about related to parabolas. The good news is most of these words you should already be familiar with through our discussion on absolute values back in an earlier chapter. So take a minute and copy down these two graphs into your notes. Pay attention to just where I have my points at. As long as the three dots that are on each graph are in the same spot, that'll be good. So you probably want to pause the video to do that. We're going to do the first one together, and then I want you to try out the second one. So, you have an example of a parabola right here, and there's a lot of different vocab going along with it. The vertex of a parabola works very much like the vertex of an absolute value graph. It's the place where it changes directions. It's either the highest or the lowest point on the graph. And you can see right here, if I'm following along the graph, I'm going up, 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 then I stop, and I start going down, 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 down. The vertex is this point right here, the place where it changes directions, right, and that is at -1, 2. We refer to the vertex as either the maximum point or the minimum point on the graph. If you think about max, if you're at the max you can be, you're as high as you can go. It's not going to go any higher. If it's a minimum, that's like the smallest you can get to. So it's just a matter of saying, is this point right there a maximum or a minimum? It's the highest point, so it is a maximum. So we have a maximum on this graph. There is no minimum, actually, because the graph is just going to keep going down as it goes right here. There will be no smallest point. So there's a max, but no minimum. The axis of symmetry, remember, that's the line that slices your graph in half. And if I drew in a line right here, the axis of symmetry will always chop through your vertex. And as you recall, it's a vertical line. Vertical lines are x equals number. And in this case, my axis of symmetry is at -1. So my axis of symmetry, x equals -1, the line that chops it in half. We did domain and range with our absolute value graphs earlier on, and it's the same sort of deal. Actually, it works pretty much identically to that. The domain on these, if you look at the graph, it's going to keep going left, it's going to keep going right, it's going to hit everything on both sides. Domain is all real numbers, as it will almost always be in quadratic graphs. And the range is going to be from this point right here, where my marker is, down. All the points down here are used, nothing above my marker is. The way I say that, it's y is less than or equal to 2. Finally, I have two extra little things here on the bottom, just another nice use of the axis of symmetry. It turns out that if you know a point on a parabola, you can get another point by using the axis of symmetry. So I have this point over here, P. Because of the axis of symmetry, P is 1 unit away from the middle. If I go 1 unit this way, I hit the dotted line. If I go 1 unit on the other side of the dotted line, I'm going to get to another point, which I'm going to call P prime. You probably talked about P prime and like the using that symbol back in geometry with reflections and stuff. It's the same sort of deal. P prime is located, again, I just counted 1 unit to the other side. That's at 0, 1. And finally, Q prime, here's Q. Q is 2 units away from the line. I go 2 units on the other side, reflecting it over the dotted line. Q prime appears to be at -3, 2. So it's kind of handy because if you know a point on a quadratic, you can get another point just by using that axis of symmetry. So try to do this problem start to finish for yourself. I'm going to power through it right here and give you guys the answers. Vertex on this one is 1, -1. It is a minimum because it's the lowest point on my graph. Axis of symmetry is the dotted line right there that chops my graph in half. That's going to be at x equals +1. Domain is all real numbers. Range, y is greater than or equal to -1 because it's going up, so it's greater than. P prime, count 2 spots, it's going to be right there. P prime appears to be at 3, 3. And finally, Q prime, if I flip the point over, is at 0, 0.